Hey math students, this is a tutorial for Algebra 2A's checkpoint 11. We're going to go through the first couple of questions that appear in your checkpoint. Now I say the first few, they might jump around and mix around, so just make sure that you're looking at the right question as I'm showing in the video. So here we're giving this function, and all of lesson 11 was about the key features of graphs. So what are like the critical points and the key understandings that we want to take away from a graph? To me, the hardest part was the vocabulary and the way that we write things in math. The concepts were okay, but like how to write them in math was a little tricky. So I hope to clarify that. So first, let's just analyze this function that we're looking at right here. So I can see that we got this little bit of a curve, and I can see these arrows that are going up and down. Those arrows are describing the end of the graph. So they are describing the end behavior of the graph. I can also see that this graph is crossing the y-axis here. So that's a key, that's an important feature of this graph. I got a y-intercept. And then likewise, I am seeing it cross the x-axis here, so I have an x-intercept here. So I've got some end behaviors, I got some x-intercepts. Another thing that we might be able to describe is how this graph is behaving, if it's going up or down. So remember, if I were to read a graph, I always read from left to right, just like we read English. So I imagine like hiking, because I do that. If I were to hike this graph, I would be going up, oh, a little bit of a false summit, you're not there yet, okay, and then up again. So I'm always going up. So all of those are ways to describe a graph. So which one is being captured in our down below? Okay, the y-intercept is at 0, 5. Yes, we identified that. The x-intercept is at -2, 0. Yep, we identified that. But what we didn't talk about is the domain and range. So I'll pop back up to the graph to talk about the domain. The domain is saying what values of x, so what numbers can I plug into x here that work in this function. So for example, if I plugged in a value of 1 for x, would it work in the function? Yes, and it's because I can see a point on that graph at 1. So I kind of just scan along this x-axis or along this graph and say, okay, is there a number that won't work? I can be a fraction, right? I can be a tiny little number right here and it still works. Okay, that's fine. I can be a negative number and it still works. In fact, this graph keeps going on forever, so I think it's going to work forever. And that's exactly what the domain is. It's all of them. So the domain is all real numbers, and then same with the range, it is all real numbers. The range is the y values. So if I were to look at this function for y, so now I'm thinking up and down, just like my y-axis, what y values work? Well, I can be a positive number, I can be a negative number, and I can be as big of a positive number as I want, because that keeps going on and on and on forever. I can be a number that's in the middle because it's working in the middle there. So it's all real numbers. So that is one question. Okay, another question is more of a drag and drop. Match each phrase with the part of the correct. Okay, so I'm going to have to zoom out. So the zeros. Okay, zeros are pretty easily identified. I think we've been talking about zeros, x-intercepts, solutions. All of those are the same word. We're going to identify all of those x-intercepts right here. So I'm going to find that solution down below. And then drag and drop. So -2, -1/2, and 3.1. Okay, the function is positive. Okay, so now we get to walk the graph. Walk it out. Okay, sorry, that's an old Bat song. Okay, so walking the graph. I'm going downhill here, down, 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 but then I turn, and what is happening? Okay, there it is. I turn, and I'm walking up to the max right here. That is the only piece of the graph where I'm walking up. So that's the only piece of the graph that is positive. So it looks like this function is positive from this x value to that x value, roughly, right? So where does that match up down below? from, oh, you know what? I did it wrong. Disregard. I was looking at increasing and decreasing. I am so sorry. Disregard. Function is positive. Duh. So I was overthinking it. So where is the function positive? Well, where are the y values positive? So all of this graph right here is all positive. So I want to describe this little section. I need to describe this section. So all the way from negative infinity to 2.5, and then that negative 0.5 to 3.1. So then where is it negative? Well, again, we kind of flip it and reverse it. Where is it going to be in negative? It's these little, it's where my y values are negative. So I'm looking down here, and my y values are this little section. So it's from 0, or I'm sorry, negative 2.5 up to negative 1.5. And then from this x value of negative, I'm sorry, 3.1, and then forever and a ways after that. So again, see the vocabulary is what trips me up. So increasing and decreasing versus positive and negative intervals. Domain and range, all real numbers, and then the y-intercept, I think we can all identify that y-intercept. So all real numbers, and then that y-intercept. Okay, number 3, what is true? So true statement, the function has a range of all real numbers. Yep, there's like no y values that it kind of skips over. The domain is all real numbers. Yep, because I can see where x's are negative. It's in the negative half of the graph. It's in the positive half of the graph. Yep. Okay, zeros and y-intercept. I think, again, we can identify the zeros, 0, 0, and then the y-intercept. I think we're all okay on that one. Okay, and then let's look at one more together. Same graph, what is true? So these, again, this is how we write the math, but these parts are describing the end behaviors. So I'm going to focus on this arrow right here. And this arrow, to me, it's on the left-hand side of the graph, and it's going up. So I need to mathematically capture those two ideas, the left-hand side and then the function going up. So let's look at this, just the left-hand side. So left and right of our graph, that is determined by the x values, right? The x-axis is what's going to the left. So I want to say as x approaches negative infinity. Sorry, that's a really bad infinity sign. Negative infinity. So what does that mean? So as x, so again, x's are left and right. So which direction do we want x to go? We want x to go towards, that's kind of the arrow here. We want x to go towards negative infinity. Negative infinity is on the left-hand side. So that's describing the left. Now let's describe the up part. Okay, what is my function doing? It's going up. What is my function's name? F of x. So my function, we call it by its name, f of x. What is it doing? It's going up. So my function going up, what's towards the most positive up value? Positive infinity. So that is how I would describe, again, that left and up. So now let's look at the right. And then this guy, it's going down, right? So here, I want to think about, okay, what's happening on the right-hand side? We're always going to start with as x goes towards what number? So what's like the most right number, right direction number that we can go towards? Well, it's positive infinity. So as x approach positive infinity, now we can talk about the down part. My function's name, we call it by its name. My function is going down. What's the most down number we can think of? So it's going to be negative infinity. So if we take all of my mumbo jumbo, that is exactly what we have here. So as x approaches negative infinity, so negative infinity on the x, that's very, very far left. So what's happening on the left-hand side? My function approaches infinity. My function is going up. So I hope that helps with a lot of the vocabulary. Sorry about my small mistake. Glad we got it. Thanks.